All right, so we've just finished composite figures, and now we're going to be talking about volume of prisms. So how is finding the volume of a rectangular prism and the volume of a triangular prism alike, and how is it different? All right, so you can see here that we're talking about two particular shapes. The first one we're going to talk about is a rectangular prism. Okay, it takes a little bit of practice, I know, to get used to drawing these figures. I'll just give you a quick little tutorial if you've never drawn one before, kind of like a cube, if you will. I like to start with the front face of the rectangle, so I just draw myself a rectangle. And then I start with this corner, and you can go in any direction, but I tend to go to the right. And I'm going to draw a line segment here that's kind of at an angle. And then I come over here to this corner, and I draw the same line in the same angle, right? Same direction. And I come down over here, and I do the same thing one more time. Now from here to here, I just draw it straight down. From these two corners, I draw straight across. And now I've drawn the front side, the part that I can see. And then I can do the same from this corner up. This one's going to be a dotted line to show that it's kind of like behind it. I draw a line straight down to that corner, and then I go across. And that creates a three-dimensional shape, showing you that these three sides are you can see, and this side over here, this side over here, and this back side you can't see at this time. Okay, it creates a little box. It's called a rectangular prism. The other one is a triangular prism. Okay, right next to it. Again, for this one, I would start off with drawing yourself a triangle. Draw yourself vertical lines down. Draw yourself across. It's pretty simple. And then from here, you look at this line and you mimic that line, but with a dashed line. Go straight down with another dashed, and then from that corner to this corner. That creates yourself a triangular prism. Okay, so anyway, enough with the drawing. Let's talk about the key concepts. So today we're talking about volume. This is stuff you've learned again in 6th grade, but we're going to go ahead and visit it again. And if you've never seen it in 6th grade, well, welcome to volume. So the volume, V, of a rectangular prism is the product of the length, that means you're going to multiply the length, the width, W, and the height. So three different things get multiplied. It can also be written as the area of the base, notice big B, the area of the base, times the height. And we'll talk about that in a little bit. So as an equation, you'll see them like this. Volume equals length times width times height. Okay, and the reason I'm using cursive L here is to kind of help differentiate between that and a lowercase l. Lowercase l just printed out looks like a 1, right? So that's why in math you'll see things using cursive so that you don't mistake that for a 1. Anyway, over here, volume is equal to big B, the base, times the height. So those are two different ways of looking at it. Let me show you what that looks like. So on a rectangular prism, I have a length down here. I have a width that goes back, and I have a height that goes up. 3 different dimensions. Okay, so if I multiply all those 3 numbers together, that gives me the volume. It gives me how many little square boxes fit inside this. And we'll talk more about this in class. The other way you can think about it is if you find the base, the area of the base, that means you take the length times the width. That's the area of the base. That's this part. Okay, that's the big base. And then you times it by the height. That's the same thing as length times width times height. So you can see the base is the same as length times width. It's finding the base, and then you find out how many layers of that you have. All right. So let's do an example here. So find the volume of the rectangular prism. So if you got this rectangle, I'll just draw it again so it's not in my notes here. And this rectangular prism tells me that this is 5 centimeters, this is 4 centimeters, and the height is 3 centimeters. So this is almost like saying the height is 3, so there's 3 layers of this particular shape. Okay. You don't have to draw this, but I'm just trying to show you. There's 3 different layers. 4 across, so that means it goes 4, 1, 2, 3, and 4. Okay, so there's 4 layers of that. That would go this way too. Yep. Let's draw that, draw that, draw that. Okay, it's not as important. And then 5 this way. So 1, 2, 3, 4, and 5. So if you actually did the math there and counted how many blocks there were in there, you could figure out the volume. But instead of having to do all that drawing, what we can do is we can just use the formula and say, look, there's 5 across, there's 4 this way. So this first layer, if you will, this first layer right here, if you can see it, of blocks, is made up of 20 centimeters squared. That's the first layer. But how many of those layers do I have? Well, I have that layer. Then I have a second layer here. And I have a third layer here. 3 layers. So that's why we multiply by 3. And we get 60 centimeters cubed. This time it's cubed, 3-dimensional, because really what you're doing is you're taking 5 centimeters, times it by 4 centimeters, and then times it by 3 centimeters. So the number portion is 60, and then the units here gives me centimeters cubed. It's a 3-dimensional shape, okay, different from our 2-dimensional shapes. So there was the answer right there. Okay, so there's a picture of how I figured this out instead of just I just multiply all the numbers, Mr. Ramos. No, you need to know that there's little blocks in here, if, imagining the blocks, and that if you were to multiply them, you can figure out how many the first layer is, and there's 3 layers of that, so there's that answer. Let's take a look at another one, key concept. How about a volume of a triangular prism? It's going to be very similar, but slightly different. The volume of a triangular prism is the area of the base times its height. This is the formula. So you say the area of the base. What are you talking about? Well, let's take a look. I've got this triangular prism. Okay, the base. This is what gets a little bit tricky. The base is going to be the same. If I were to lay this shape on its side, this base is going to be the same as the top. So whether I flip it here or flip it the other way around, it's going to be the same. Okay, so find the area of the triangular prism below. So I've got this triangular prism. Looks like a ramp, if you will. And I ask myself, what's the base? Is the base the thing that's laying flat on? You say, no, not really, because look, I don't have a rectangle sitting up here. That would be the exact opposite. The base happens to be this part over here, because right on the opposite side, it's got the same exact shape. So there's my base. I find the area of the base. Well, area of a triangle here is 6 times 8 and cut in half. So 6 times 8, okay, 48, cut in half, 24. Once I found 24, what I've really found out is, look, I found out that this shape, I'll go ahead and draw it on here, this first layer of this, if you pretend if it was a cake or something, I don't know if that's right, 1, 2, 3, 4, 5, 6, 7, 8, 9, okay, whatever. If you found out that this first layer right here has got an area of 24, and then how many layers do I have? Well, I have 9 layers of it, so times it by 9, and I get 216 feet squared. So I'll talk more about it in class, but really we're going to talk about these type of shapes. This is a triangular prism, okay? And so what I want to show you here on this triangular prism is that, look, if I thought this was the base, if I were to lay this flat, I'll show you the side version, just lay this flat, you can see that there's not another rectangle on its opposite side, right? If I thought this was the base, right, I laid it flat. If this was the flat side here, you can see that there's not another parallel shape that's exactly the same. So these are not the bases. None of these rectangles here are the bases. The bases is going to be the actual triangle. That's why it's called a triangular prism. Because if you look at this triangle, lay it flat, exactly on the other side is the same triangle. So that's how I know which ones the bases are. And so next time when you're given a triangular prism, you find the area of the triangle. You make sure, oh, hey, there's another triangle on the other side. Good. Area of the triangle, and then you just multiply by its height, or how many layers of that particular triangle you have. Okay, we'll talk more about it in class. Be prepared for tomorrow.